Good question. And I don't know if you may have run across that in the textbook when you were reading this section. But yeah, the endo product is always going to be favored. All right, what about C?
It's the same.
It's very similar to B, isn't it? All right, you're going to get here, here, and then here. That's your mechanism. You're going to have a 6-membered ring. Is that right?
Mhm.
You're going to have a double bond here, well, a pi bond here, and then your acids, just like we did up top. Right. Only thing I'm missing is what?
The bridge.
The bridge. And we can point that out over here, right? These carbons right here, these are going to be your bridge carbons right here. Come on, Russell. Right, so we could just draw those in over here. Just like that. And if we were to draw this in 3D, it would look like this. It's going to look kind of like a handbasket. Right. So those bridge carbons are always going to be pointed up out of the way. But we really didn't get into the 3D aspect of the DLSR because we just pressed for time right now, so we got to keep rolling. Does anybody have a question about that? All right, let's do some of the ones we go ahead.
I'm good.
Okay. Let's do some of the ones where you have to work backwards. And I'm going to ask.
Dr. Russell, I have a question.
Go ahead.
For the ones with the triple bonds, do we not worry about the stereochemistry there?
Well, notice the stereochemistry was, you see how it's linear right here?
Mm-hmm.
So there is no stereochemistry on a triple bond.
Oh.
It can't be cis or trans.
Okay.
So both groups are 180 degrees. So by default, when you show those groups in the product, they're going to be cis.
Okay.
Yeah,
Thank
good.
you.
That's a good question. I'm glad you asked that because I know somebody else was thinking that. That's a great question. All right, we need some volunteers to annotate the screen. A, this is all retrosynthesis. All right, so how do you work from this product back to the 2-star materials?
You can number them.
You want me to number? All right.
I can try.
Come on. Might as well. It's Friday. Where are you going to start?
The carbon.
Jalen, you like the silent assassin. The double bond.
Yeah.
Okay. I agree with that.
Mm-hmm.
Go ahead. Keep rolling.
I'll
Don't get scared now. You done wrote on my screen.
erase it. That's fine.
No, don't erase it. That arrow is correct. You just need to keep going. Because you're gonna have to break this bond now, right? Because if you don't, then the carbon at number 1 is gonna have too many bonds to it. So where would your next? Okay. I'm with you. And then there's one more arrow. Okay, that arrow that you just drew in right here, you have that one going the wrong way. Great. So now what do those arrows mean? What do they indicate? Don't they indicate that I'm going to get, I'm trying to keep it. Bad idea.
I can redraw the arrows.
No, that's okay. I shouldn't have zoomed it. I think this will suffice.
Okay.
There we go. All right, so those arrows are telling me that I'm going to put a pi bond between 1 and 2,
Mm-hmm.
a pi bond between 5 and 6, and a pi bond between 3 and 4. Is that right? And I'm also breaking the sigma bond between 1 and 6 and 4 and 5. Are you following that?
Yes.
Mm-hmm. So this is the most basic that's your most basic Diels algebra. Hold up, let me get this out of the way. I didn't realize that during the recording that little gallery is always up there. All right. Any questions about that?
Nope.
All right. What about the next one? What do we have to take into consideration in the next question in B?
It's trans.
Stereochemistry. Good. Well, I'll tell you. I'm glad I got up this morning for this. I just made my day. So the stereochemistry of the dienophile, is going to be trans, right?
Yes.
All right. Can somebody put the arrows in for that one? And I hope they approve this. Okay. 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 Who is that drawing that?
Sage.
The great sage. Calming everybody down.
I'm trying.
We appreciate you. I like the fact that we can annotate the screen so you can't get out of coming to the board. So that's my diene, is that right?
Yes.
And then my dienophile is going to look not like that. Like that. With an aldehyde here and an aldehyde here. All right. Any questions about that one? Or anything that we've been talking about?
Nope.
All right. Do the last one. And then I think we could do one. We could do a couple of these harder ones down here. I think that's really the end of all the questions too. Let's do the last one. Somebody take a crack at that one. Anybody gonna take a stab at it?
I don't know how to draw on my screen, but I can describe it to you.
Okay, go ahead. Describe it. Tell me where to put my first arrow.
The top left corner, top left bond that goes towards, yeah. And then the following bond goes towards that double bond, which
Like
one
that?
with the triple bond,
Mhm.
and then the bond connecting the two. Yep.
So what can you tell me about this product based on what we've already done so far? What can you tell me? About the
It's a
diene.
triple bond
Not the diene. The dienophile was a triple bond. Can we agree on that? And how do we know?
because it has two pi bonds.
Two pi
And
bonds in the product. That's exactly right.
stereochemistry. There
Yeah.
is none.
That's right. And under normal circumstances, a Diels-Alder product will only have one pi bond, right? So here, this would be that plus this. Is that right? Can everybody see that?
Yeah.
All right. Any questions? All right. Let's do one more. One of these hard ones down here. What do you think about this one? It looks like a lot, but it's not. This first one. Let's see if we can break that apart. It's a retrosynthesis. It's asking you, anytime you see a big arrow like that, that's a retro arrow. It's working backwards.
Would you do the double bond that's over on the left side?
Yes, this one.
Yeah.
Yeah, you want to start with that one. You want to start with that one. That's a good observation. You definitely want to start with that one and not this one, right? Because number one, if you move this double bond, all you're going to be doing is resonance, right? You're not going to be. It's not going to be end up being a retrosynthesis. You just end up doing resonance. So that's a good observation. So let's go. Let's start here, like that. What do you notice about this? Because that's my Diels-Alder part right there. What do you notice about it? Got a bridge, doesn't it?
And, yeah.
The bridge head carbon is right here, right? So when you see that bridge, what have we been doing with these problems that have a bridge like that?
Ignoring it.
Ignore it. That's a good way to say that. Don't touch it, right? So I'm gonna do this. And I'm gonna take these electrons and put them here. So what are my two star materials? You know this is gonna be one of them, right? Let's go ahead and get the easy one out of the way. Is that right?
Yeah.
Yeah.
And then what does the diene look like? This is my dienophile.
Wouldn't it be a 6-member ring with double bonds at the 1 and 3 carbon?
Yeah, it's actually a 5.
Yeah.
Yeah, you see the number of carbons. Let me erase all this highlighted stuff. So it's a 5-member ring. So it's 1, 2, 3, 4, 5.
Yeah.
All right, we're okay with that?